So this morning I wanted to do something a little bit different. Instead of just having a video explanation and then you do an assignment, I wanted to do something called an Edpuzzle. Basically, I can take a video and insert questions in it, and you guys have to correctly answer those questions to go on to the rest of the video. So I'm planning to do this as a review for a short quiz I have planned for tomorrow. It's nothing that you haven't seen before if you've been keeping up with your assignments. So that being said, what I'd like to do is I'll work out a problem and then you work out a problem very similar to that one, but you have to input your answer to move on to the next part of the video. So we've done basically 5 different types of equations so far. We've done equations where you had to simply add or subtract to get your solution. We had what I call two-step equations where you had to add and subtract and then get rid of what's called a coefficient, combining like terms, variables on both sides, and the distributive property. I will run through all of that again as I work through a problem. Again, it might be a little bit longer video than normal, but there's no assignment afterwards because your assignment's kind of in the video. So the first type of equation we did was where you simply had to add or subtract depending on the setup of the equation to get your solution. So this one on the left here, I've got negative 14 equals n minus 8. It doesn't matter if your equation is reversed. A lot of people seem to like the variable better on the left. So if you're struggling with these, you might want to, flip-flop the sides of your equation so your variable's on the left and you can have a little bit better setup from that one. So since 8 is being subtracted from n, my job as the person solving the equation is to do the opposite of that. So in this case, I'm going to add 8 to both sides. If the 8 had originally been added, I would have turned around and subtracted it. Your goal is to create inverse operations, basically addition and subtraction, one way or the other, undo each other. So when I add those together, negative 8 plus 8 cancels out. N equals negative 14 plus 8 is negative 6. Moving right along, I've got another pair of equations. This time I would call these two-step equations because you have to do 2 steps of arithmetic to solve them. So I don't just have a plus 6 on the end of it. I also have this multiplier out front attached to my a, or attached to my variable. So I also have to contend with that and take care of it at the end. But the first step is still the same. Whatever this constant number is out here being added on or being subtracted off, that's what gets dealt with first. So that leaves me, the 6a just drops down. And over here on the right-hand side of my equal sign, 102 minus 6 would be 96. Divide out your 6. Anytime you see the 6 and the a smushed up together like that, it's multiplication, so you have to divide. So if I divide out 6 from both of these, my a value, 96 divided by 6, is 16. You try the next one. These two types of problems I would call combining like terms. Like terms are pieces of your equation that are the same. Either they're the same variable expression or maybe they're the same constant expression. The one on the left, I have 2 variable terms that are the same, and the one on the right, I have 2 constant terms that are the same. In either scenario, your job is to combine those 2 terms before you move on. So on the equation on the left here, combining these 2 terms, I'm going to simply add them together. Negative 1 plus 4 is 3n. The left-hand side didn't change, it's still negative 21. Again, that coefficient attached to the n gets divided out. My solution's negative 7. Try the next one. Okay, this is very similar to the last one where you have like terms. The issue with these is that your like terms are on opposite sides of the equal sign. So I can't just add them together. I have to physically remove one of them from one side to get it over to the other. Now it doesn't matter which way you go if I were to move the negative 3k or to move the negative 6k, but in my experience, if you move the smaller of the two, in this case, -6 is smaller than -3. If that's the one I focus on canceling out, when I do that, when I add it to both sides, I'll wind up with a positive number instead of a negative number. It'll work either way, but I feel that it's easier to move the smaller one so you get a positive. So when I add 6k to both sides, -3k plus 6k is now positive 3k, equals is still in the middle, 2 on the right. Our goal when we do this is to, each time we do a step, is to make it a simpler equation to look at, to have less work to do after that. So now I've got one of those two-step equations we were just talking about. I'm going to add 4 to both sides. Again, I'm saving this coefficient for the very end. 3k equals 6. Divide out your 3. K is 2. Try the one on the right. The last type of problem that you worked with, this should have been your assignment from yesterday, is to work with parentheses using the distributive property. The distributive property basically says, without a whole bunch of fancy math jargon, it basically says if I have a number outside a set of parentheses, I can get rid of that by multiplying it into the parentheses. So I'm going to multiply 6 and 1 and 6 and -5. You're doing two multiplications because you have two numbers inside the parentheses. -84 equals 6 minus 30b. Okay, I've got that back down to a two-step equation. So I can get rid of my 6, subtracting because it was positive. So that gives me -90 equals, and then this whole section just drops down, -30b. Divide out my -30. That's a big coefficient, but it still works. -90 divided by -30 is 3 for B. Try the one on the right, and we're done. You have a short quiz tomorrow.